Okay, so question number 10. See what we have to do here. So it looks like we have to calculate the enthalpy chain for this process, knowing these two directions. Okay, so same strategies apply here. You have to write out the main process that we have to calculate with all the coefficient numbers and the state as well, because it matters. Okay, so next step, we're looking for each of these elements, how they will be formed. So actually, okay, I'll make a small mistake here. Okay, so actually we see that SO2 is formed from the first reaction here. So from sulfur and oxygen, sulfur is in solid form and oxygen is in the gas form, we can go to form SO2. But this process is for 1 moles of SO2 being formed, where we have the 2 as a coefficient number here, so make sure that you do the balance. Okay, okay. So 2 here, and because in this reaction we have the extra oxygen here, so we have to include that as well, because with just this, we'll only mix do this. But adding oxygen here and here actually make the reaction the same, okay? And for this process, the delta H is minus 283, but since we form 2 molecules of SO2 here, so that would be 2 times minus 283, okay? And we also see that from sulfur and oxygens here, we also can form 2 molecules of SO3 as well, and that process is represented in the second reaction. So this process, energies involved is minus 395, okay? So next step, we have to looking for what is the starting materials and what is the product, which is the indirect, which is the direct process. So it looks like we can go from here directly to here, and the rest will be indirect, okay? So now we can write out the delta H direct equals to the delta H indirect, okay? So the delta H direct will be the minus 395 equal to indirect is 2 times minus 283 plus the delta H of the unknown process that we have here. So the final delta H that we are looking for is minus 395 plus 2 times 283. So that one would give you the final answer is minus 196, and that would be A.